This is a Unit 3 review for Chapter 2. To find the x-coordinate of the vertex, you can take negative b divided by 2a. For this one, that's, my goodness, my b's and 6's. All right, let's make that a capital B. Negative b divided by 2a is equal to negative 6 over negative 6. So that just reduces to 1. The x-coordinate of my vertex is 1. If I plug that in, I find that my y value is also 1. So there's my vertex at 1, 1. There's a connection between vertex and axis of symmetry. The axis of symmetry is the vertical line that passes through the vertex. So while we can say that the vertex is the point 1, 1, the axis of symmetry is the line x equals 1. Let's do the y-intercept next, which means we're going to plug in 0 for x. When that happens, this goes away, and we are at negative 2. And I'm going to sketch the graph, so I'll go like this, which means there's symmetry on the other side. And there we go. Let's see. Y-intercept is negative 2. And I've done all of them. Next up, if I think about the parent function, this is a parabola, this is a quadratic. And because there is minus 2, that means I'm going right 2. Because there's plus 3 over here, that means I'm going up 3. And because of this negative right here, that means there's a reflection. And this will be facing down. So let's start here at 0, 0. And we'll move to the right 2 and up 3. And this is our new vertex. This one is gone. That's our new vertex. I could plug in 0, and that would help me find another point. It's not quite as easy as before, but if you plug in a 0 here, that's going to be negative 4 plus 3, which is a negative 1. So here we are at 0, negative 1. And this is a sketch of the graph. So what do we know so far? Well, from this form, the vertex is 2, 3. That means the axis of symmetry, the vertical line that passes through the vertex, is x is equal to 2. My y-intercept is going to be negative 1. That's where the graph is when it crosses the y-axis. To find the x-intercepts, this one's a little tricky. You could, on a calculator, press second trace, which brings you to the calculate menu. And you could choose 0, and you have to choose a left bound and a right bound, which means for this 0, you'll choose a left bound and a right bound, and it will find the 0 within that range. And then you'll do the process again, a left bound and a right bound. It'll find the 0 within that range. You could absolutely do that using the calculator. It would give you decimals. We can also expand this algebraically. This right here, squared, looks like this. We can use the box method. And if I put a negative in front of all that, that's negative x squared minus 4x plus 4 plus 3. So that's negative x squared plus 4x minus 4 plus 3. I'll just erase that and write minus 1. What you probably notice at this point is this is not factorable. We can't use our x method or our x box method. We would have to use the quadratic formula. So let's assign values to a, b, and c. And let's test our singing voices. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. If we fill everything in like this, we can simplify what's underneath the radical. We call that part the discriminant. 4 squared is 16, and there's 3 negatives, so it is going to be subtraction. 16 minus 4 is the square root of 12. And this part I can leave like that, and this part I can put like that. So there's some simplification that can happen. I can write this as 2 plus or minus the square root of 12 over 2 if I wanted to. And I could put the negative here, but because it's plus or minus, if you add the negative, it's like that's the minus, and if you subtract the negative, that's the plus. So I don't really think I need to do it. That would give me the x-intercepts for this one, in case you wanted to know. Next up, they want the parabola in standard form. Now, I'm going to argue that we could call it vertex form. That's what they're looking for. They're looking for in the book they call it standard form, but the one that has x minus h and k at the end. I'm going to use the algebra formula. The x-coordinate of the vertex is negative b over 2a. So that's negative 6 divided by 2 times 3, which is just negative 6 over 6, which is negative 1. To find the rest of the vertex, I can plug that in. 3 times negative 1 squared plus 6 times negative 1 plus 2. That's 3 minus 6 plus 2. That's also going to be negative 1. So my vertex will be negative 1, negative 1. I can think about the parent function and write it like this. X minus h, which is like minus a negative 1, so really x plus 1 squared, and then minus 1 from my vertex. And my a value here is 3, so I'll put that over there. So I'll write this f of x is equal to 3 times the expression x plus 1 squared minus 1. For this next one, I think if we pay attention to the different transformations, it will help. This is my new vertex, which means from the parent function, I went right 1 and up 6. I also see that it reflected upside down. And then I would expect, as I go 1 to the right, I would expect a certain value. For example, when I plug in 1 for x, what normally happens? Well, 1 squared is 1, so I'd expect to see the coordinate 1, 1. Now we're upside down, so it's backwards, but instead of going over 1, down 1, I actually go over 1, down 2. So it's double what it should be. So that's a scale of times 2. How do I write the entire formula then? So let's write y is equal to, and inside parentheses, let's write x minus 1. That's where the right 1 will go. We'll put squared. And we're going to put plus 6 for the up. We'll put a negative over here for the reflection. And we'll put a 2 right here. If I wanted to scale it times 2 inside the parentheses, I would have to take the square into consideration. And I'd have to use the square root of 2. And it would change a little bit because I'd have to distribute the 2 as well. I think it's much easier to think of this as a vertical stretch for this particular problem. This next one, let's start with the vertex and write that as x minus 2 squared minus 4. And we can put an a here and an f of x over here. We're going to plug in this point. So we have 3 minus 2 squared minus 4 is equal to negative 1. And this is the other way to find if you have an a value. Rather than just looking at the graph and counting over what it should be, you can figure out, does this actually give you negative 1? If not, you need an a value. So here you can see this is 1 squared minus 4, which doesn't work. So let's go ahead and put a 3 there. And if we do that, then it's 3 times 1 minus 4, and now it works. So our function is 3 times x minus 2 squared minus 4. We're looking for the greatest common factor here, and negative 2x squared can be factored out, and then we have 2x minus 1. To find the two zeros, this one is 0, and this one, you can set it equal to 0. 2x minus 1 is equal to 0. Add 1 divided by 2. You're looking at 1/2. Those are the zeros. For this next one, we can factor out a 3x. So the front one becomes x squared because we divide, and the next one becomes 5x, we divide, and the next one becomes 6. Remember, this is like the opposite of distributing. It's called factoring. You look for the greatest common factor and pull things out. I can then take this quadratic and use the x game to factor this, or the x method. If you forget how to do that, it's a 6 and a 5. What two numbers multiply to give you 6 and add to give you 5? It's 3 and 2. I can write it like this. So this is a 0, this is a 0, and this is a 0. To describe the transformations over here is down 3. This negative represents a reflection across the y-axis because it's inside the parentheses. And this 3 being inside the parentheses creates what's called a horizontal shrink. For this next one, the negative because it's outside the parentheses, is a reflection across the x-axis. The 2 being outside the parentheses is a vertical stretch. The -4 inside the parentheses means a translation, right 4. And the +5 at the end means we're going up 5. So a bit of a recap, if we have the quadratic 5x squared plus 4x plus 2, the 5 is known as the leading coefficient, and the 2, which is the largest exponent, is the degree of the polynomial. There's 4 potential outcomes here. Your lead coefficient can be positive or negative, and then the degree of the polynomial can be even or odd. What these tell us are the end behaviors of the polynomial, or how the graph behaves at the left and right. So for this top left one, it goes up on this end and up over here. If you were to look at a graph, that would look like this, for example. This other one goes down on both sides. If we were to look at a graph, that would look kind of like this. Those are both even degree polynomials, just the quadratic. For this bottom left, we go down on the left and up on the right. Think of the cubic graph. Or the opposite, we go up and down. Think of the cubic graph flipped upside down. Now, do you need this shortcut? Honestly, no. You could just press graph and eyeball it, but it's a nice little trick to have. Because this one has a leading coefficient that's positive and an odd degree for the polynomial, on the left it goes down and on the right it goes up. This next one has a negative leading coefficient and it has an even degree, so it's going to go down on both sides. This is like the left and this is the right. I guess I should have labeled this is the left and this is the right. So to find these zeros, let's set it equal to 0 and then multiply both sides by 5. That's a great way to get rid of these fractions. The next thing I'm going to do is I'm going to look for the greatest common factor that I can pull out of here. So this gives me x squared plus 7x plus 6. And then I can change this to x plus 6 and x plus 1. I use the x method there with a 6 on top and a 7 on the bottom, 6 and 1. So they want us to find the zeros. Here's 0, -6, and -1. This next one, let's factor out a 2, x to the 4th minus 20x squared plus 64. And I can almost treat this one like the x game, like 64 is on top and -20 is on bottom. And I'm looking at -16 and -4. But here, it's a little bit different because it's going to be x squared minus 16 and x squared plus 4. Oh, excuse me, that should be -4. You could do it without factoring out the 2 first, but it just means bigger numbers. For this last one, with these zeros, they have the factors of x plus 3, x plus 1, and x minus 4. So if I was to multiply all of those, it's for sure going to have an x cubed. So the least degree possible is going to be 3. All right, I'm going to post this for now, and I'm going to make the rest of the video after dinner. We got dance tonight.